Let us take the first example. Write a program to generate a square wave of 50% duty cycle on the port pin P1.3. So we have to set the port pin P1.3, give a delay, and then again clear it, give a delay, and repeat the process. So set B P1.3, call a small delay routine, clear P1.3, call a small delay routine, and sjump back to repeat. So this keeps on. It is setting for some time and resetting for some time, and you will be getting a square wave of 50% duty cycle. Since frequency is not mentioned over here and it is given only 50% duty cycle, a random delay routine is being written and it is uniformly called. Therefore, we get 50% duty cycle. This is the delay routine. Some random count or some random value is being loaded into R0. It is decremented and then it is repeated again when the routine is called. Let us take the second example. A switch is connected to pin P1.2 and an LED to pin P2.0. We need to write a program so that we get the status of the switch and send it accordingly to the LED. So let us assume that the anode of the LED is connected to the port pin. So whenever the port pin is high, the LED will be glowing since it is connected to the anode and the cathode terminal of LED is grounded. So if the switch is off, then the LED also will be turned off. So we have to first make P1.2 as input pin, get the status from it, and then we have to pass it on to pin P2.0. So to program pin P1.2 as input pin, we will use the instruction setB P1.2 and we will use the instruction move C, P1.2. Now P1.2 is a single bit, it will be copied to the carry flag bit, C bit. Then move P2.0, C. The C value will be stored into P2.0. So since the anode of LED is connected to P2.0, if the pin P1.2 is high, it is stored in C. C value will be stored over here. Therefore, the LED will glow. If P1.2 is 0, then 0 will be stored in C. That will be copied to P2.0. Therefore, the LED will be off. And this process keeps on repeating. 10 bytes of data are stored in locations 40H to 49H. Write a program to check whether a byte n is present in any of these locations. If present, then store FFH in the register B, assuming that n is present only once. So we will store the starting address of the array or the memory locations in the register R0. So move R0, #40H. There are 10 data bytes, therefore we'll store the count in the register R3. We will get the first data from the location 40H. So move A, at R0. And then we will compare it with the byte n. CJNE, compare and jump if not equal to skip. So if the first value in the location 40H is not equal to the value n, then you increment the increment the pointer so that it points to the next memory location, decrement the counter DJNZ R3 and jump back to repeat. If it is equal, which means the byte n is being found, therefore move FFH to B and sjump to n. Terminate the program. Write a program to find sum of given n numbers stored at the location 40H. Store the result in register R2 and R3. So we will load the starting address to the register R0 and we will assume that there are 4 numbers and we will load the total number of numbers into register R1. We will clear R2 and R3 so that we can store the lower byte and the higher byte of the result. Clear the accumulator, clear the carry flag. Load the first value into the register A, add it with R2, right now it is 0, store the value in R2. Clear the accumulator, load R3 to A, and if there was a carry in the previous addition, that has to be stored. So ADDC, add with carry A, 00H, store that value in R3 and then clear A. Increment your R0 so that it points to the next number in the array. Decrement the count and jump back to L1 location to repeat the process. Once the all four numbers are added, you will find that the lower byte is stored in register R2, higher byte is stored in register R3, and the program will be terminated. Write a program to find the maximum number from a given 8-bit 10 numbers stored in locations 40H onwards. So the starting address is loaded into R0. There are 10 numbers, so count is stored in R4, and we need to find the maximum number, so we are initializing R3 with 00H. The first value is loaded into A, increment the pointer and decrement the count. Now move 34H at R0. Whatever value was there at R0, that is your second number in the array, is loaded into 34H. Now this is a temporary memory location whose address is specified directly. CJNEA, 34H, L1. Compare the first number with the second number. If it is not equal, jump to L1. So you need to check whether there is a carry. If there is a carry, then come to L2, load the higher value number into A, because the carry flag will be set when the first number is tried to subtract from the second number, and if it is smaller than the second number. Increment the counter, decrement the count, and jump back to L3. Say suppose the first number was greater than the second number, then you simply jump to L2, and you move the second number into the accumulator. If there was no carry, you simply jump to L4, increment the counter, decrement, and then you go back to L3 and repeat the process to terminate the program. So at the end, you find that R3 will be having the value which is which holds the maximum number. Write a program to accept data from port 2 and keep a copy of it in memory. Location starting from 40H and also output it on port 3 continuously. So I have to get data from port 2. Then I have to store it in 40H and also I have to send it to port 3 continuously. So load the starting address to R0, read the value of port 2 to accumulator, store it at 40H, store a copy of it at port 3, increment R0 to point to the next location, and simply jump back to L1. So this keeps on repeating. Write a program to perform the following. It has to keep monitoring P1.2 until it becomes high. When it becomes high, write the value 45H to port 0. Send a high to low pulse on P2.3. So I have to monitor P1.2. We have to program it as input port. So set B P1.2. Load the 45H value into the accumulator and check for P1.2. So jump on no bit P1.2, comma again. It will be in this instruction itself. Moment there is a bit, move A, comma P0. 45H was stored in A, that will be moved to port 0. I have to send a high to low pulse to P2.3. So set B P2.3, caller delay, clear P2.3. Will be giving a, when you do clear P2.3, you're giving a high to low pulse to P2.3. One more example. A switch is connected to pin P1.7. Write a program to check the status of the switch and perform the following. If switch equals 0, then send the letter N to P2. If switch is equal to 1, send the letter Y to P2. So program P1.7 as input pin by using setB P1.7. Read the value of the pin to the carry flag. So move C, P 1.7. If there is a carry, come to over where you are loading the ASCII value of Y to P2. If there is no carry, load the ASCII value of N to P2, and in both cases jump back to again so that you read the value of P 1.7 back into the carry flag and you go ahead. So in this week videos, we have seen 8051 programming. We learnt about assembler directives, addressing modes and instruction set. We also saw few programming examples. In this week's assignment, we have given two links over here which will discuss about how to install Keel Microvision software and how do you work using this particular software. So we would like you to go through these two videos, install Keel Microvision software in your systems, and we have listed out few set of questions, and we expect you to write a solution for two programs out of the questions given to you. Execute them in Keel Microvision software and write the program in a document. Put the snapshots of the results what you have obtained using the Keel Microvision software when you executed your program, and then submit the document to us. Thank you.